Well, so let's look at some tools. How do we get there? So yeah, we need some tool chain. By the way, incidentally, this picture is from Latvian National Library. I think it's considered some tools from librarians of past, I believe. So some of the tools of trade, so to say. Of course, I don't know what they used the fork for, right? But it was part of the librarian's tool chain. So, well, so what do we have? When we're working with text, what do we need? Well, general data in general, we have extraction, right? We need to actually extract data from somewhere. Of course, it could be a digital source, could be an analog source, right? And then inevitably, well, we will need to perform some transformation. Of course, there will be the work, this transformation part here. This is usually takes the longest. Getting something they call in English data munging, well, squeezing, moving our data into a format which is appropriate, right? That usually takes the longest time, adding metadata and so on. So, of course, then you load into something, well, something you can manage, some other format, or you're right, data formats, some database formats probably, some storage formats perhaps, and then hopefully you get to the fun part. Assuming you've done all this extra work already, preparation, then you get to the analysis when you can actually see, explore your data, when you can perform some text analysis tasks, like of course those general, you mentioned already, frequency analysis and so on, semantic analysis. And well, eventually, of course, you get to, at some point, you also want to visualize these results, something so people, so persons who are maybe not intimately familiar with the previous tasks, they can see the results and they can use them. So even from outside, don't have to be working at the library, and end users. So you want to see some, show them the results, maybe for researchers again. So that should be the end goal. So these are the parts of the tasks we perform. So okay, so well, let's look what we are experimenting right now. So again, we already saw, so there's this idea of sandbox. So what's sandbox? Sandbox is just our place for exploration, right? Adults sandbox. So again, the Jupyter notebook we'll be looking at, that's sandbox, meaning, well, it's not part of our publicly faced infrastructure. It is for inner sort of research, meaning, well, why do we need sandbox? Well, partially, of course, this isolation and security. Again, there might be issues of letting your own raw data out. Maybe there could be also copyright issues, various issues why you don't want to let your children out too early. Maybe let them grow up a little bit, so to say. So, and there's also a task of maintainability. Again, you have to solve these issues of maintainability, how to keep going on, right? And the sandbox give us quite a bit of flexibility. We can experiment, we can play around. We have a lot of, again, a lot of freedom, right? While we're developing our prototypes, while we are working towards some end user goal. And again, we can work on scalability. Again, eventual goal, sandbox itself might not be itself very scalable, but you can experiment again with these tools on, well, eventually this can be provided, the service can be provided to a wider audience. That's usually the goal. So, and again, the reliability, again, sandbox lets us solve these issues before they become, again, reliability meaning, is the service accessible? Again, so you can solve these issues as early as possible. So those are all like big picture goals. But let's look at more at some tools. So what we're using. So yes, so we use Jupyter. This is our sandbox. This provides a sandbox. Again, this is it's not just one service, right? So it's using. So what is Jupyter? It is using our familiar web interface or browser. There's saying that the browser is eating the world, right? Such as software is eating the world, and also the web browser has eaten many other services. Pretty much every service these days is provided through a web browser, and custom applications might just take a back seat. That's the reality. So again, so this Jupyter has embraced this movement it actually used to be called Iron Python a long time ago when it was just Python. But these days, actually, it supports many languages. So we see that in Estonia we use R, we use mostly Python. There's also a new upcoming language, Julia, which is very promising. But again, it doesn't really matter which language you use. What matters is what kind of results you can achieve. And again, even some other languages supported, even some other ones. So yes, in our case, we have our playground is at the lab LNB-LV, but it is accessible only internally, right? I should mention, right? Or maybe if I have time, I'll try to show you how it works again, but it's not accessible publicly at the moment, right? It's meant for internal use. So right, so let's talk about technical details. So hosting, right? We had decision, and so explored that there is something called a Little's Jupyter Hub, which fits our needs quite well. So it provides with some minimal technical, anybody from your IT department, I think, would be able to set up with some Linux experience, not too hard to set up, and you can support roughly up to 100 users. We are not hitting that many. We probably have about 20 registered users, but at the same time, maybe 4 or 5 people can use it. Maybe today we'll push it. Maybe push it to the limit a little bit more. And again, so what does it mean practically? You have your local computing resources, and you are hosting locally. So it means we have our virtual server, where we have machine with some cores, some memory, some hard drive space allocated for this task at our library. Of course, like as we saw, it's not necessary. These days, you have options. You can host, again, a Little's Jupyter Hub can be hosted on Amazon Web Service, could be hosted on DigitalOcean. Again, what it provides is something very similar we saw at Estonian infrastructure, and also Google Colab is another option. But we decided we would like to have control again, because of course the issue with hosting somewhere outside of your control is you don't know what's actually happening with your data at some point. If sometimes things break, right? So you want to actually, I personally am more a fan of hosting locally if possible. Okay, so that's technically. So I can definitely recommend. I had positive experience with this service. If you need to, let me see if I have if you need to go more beyond 100, you can install a full-fledged Jupyter Hub. It might be a little more technically demanding, but it's possible to support more than the 100 users. Again, so maybe you need more hardware, but it is possible to go more. Again, this means it is meant for mostly for research purposes, mostly. So it won't probably need more than that. So again, so our choice on language, again, Python was just mostly, again, the bias is here because I come from Python background. I teach Python at the university. So it was easier to start using it. Because again, it's syntax, just like R, it's easy syntax. But one part here I should mention is that, again, so possible to modify with little programming experience. And I teach people from 0 to, well, not hero, but something in about 30, 60 days, they can start using it. What I like compared to R, again, it's the ecosystem. If you need something which is not part of the R is a great language, but it is more domain specific. Python is very, very general. So as the joke goes, the joke a lot if Peter enters, so he can hear the joke. The joke goes that Python is a #2 language for everything. Yes, there will be always some language which will be more specific for your task, maybe better. But when you need to go wide, you'll find that Python is there to help you. And of course, usually good documentation. Again, so that's also important when we're choosing libraries. Maybe we'll talk about the tools, the libraries. Yeah, so the libraries we use them, well, built in. Some of the libraries are built in Python already, and some of them are you have to install. So JSON libraries, XML parsing libraries, SQL Alchemy for database access, Tesseract for bindings for OCR, for accessing web resource, we use request and Beautiful Soup. And then there's NumPy and Pandas for analysis, for data analysis. And I'm a personally big fan of Plotly. I was very happy to see Peter also was using Plotly because it's a great library for visualizations, quite nice compared to the built-in Matplotlib, right? And well, NLTK and Spacey, which is for these are text libraries, text analysis libraries. Well, we actually don't use them too much because, well, they are good for English language. For Latvian support needs a lot of work, a lot of training for this, meaning training the actual engines, not the people, but actually training the engines. So this is something maybe, hopefully this will change, but I'll show you what service we use. Instead we use a special homegrown service, Latvian grown for Latvian language. So where do we start? We start at the pre-processing stage. Again, we have a nice excellent digitalization library department, which usually works with their own tools. But in there are cases when you need, well, Tesseract in the last 5 years, it's grown. It was a little bit of not a joke, but it was not very serious alternative. Maybe 10 years ago, it was not working very well. What has changed? It has changed that this growth of machine learning, this deep learning, you can train the engine now much better. You have a much wider variety of data being fed in. When I say data, I mean, of course, actual words, texts, corpora. So a lot of work has been done in Germany, and of course, it helps us too. So the engines, it's getting better. And so personally, on a personal level, we've done some work here with our old Latvian texts, which don't have any training done outside, so I had to train them myself. So that's also been some positive examples of using OCR. So that's an excellent tool, Tesseract. And of course, there are already graphical interface for Tesseract. You don't have to learn programming to use it again. So that's one of the tools. So once you actually have some text already, we have it converted to some textual form. You have your metadata extraction. You have to look at typical errors. You maybe typical OCR errors. You have to see, do some verification, some cleanup. See maybe again, do just your human, do some random sampling, and maybe take a look at how well the digitalization process worked. So and then what happens usually, we work with mixture of data. We have some of our texts already in some sort of format on our local or library infrastructure on our servers, but the problem is we don't really have a wide variety of plain text, for example. And in here we're talking about plain texts. Well, you have to extract them from XMLs, from JSON, from other formats. They are not quite, so that's something we're working on, providing this plain text for researchers, which it needs, of course, this process is, those who have worked with XML could be quite hairy format, could be quite, so a lot of time spent on transforming this data from different formats. Again, this is just a small sampling of the formats you need to work. Eventual goal is text format, just regular plain text, which we all know and we all can work with. So, okay, so let me see here, maybe a little, okay, yeah, like this. So yes, so again, 80% of the work is done on this transformation work, right? So how it works, usually we use Jupyter SANDBOX, right, for this transformation. Eventually, when something is working correctly, I transfer them to standalone Py scripts, so you can run them separately. You don't have to use them in a notebook. Again, so for helping for improving your workflow. So yeah, as this comic shows, of course, they always question how much of time should be spent on these scripts. When do you save time? When can you do it by hand? We all done some cleanups by hand, but well, so it's always trade-off. Whether usually, of course, programming is maybe it may seem more productive, right? Sometimes, but if it's a very rare task, maybe it's not worth it. Again, it's always a trade-off. So, but yeah, so management tools, again, I saw that, again, Peter also was using GitHub. I think they used, so we also use, we have our own internal GitLab server where we host, and also I use private GitHub instances, meaning for the private, also public. Also, some data is public, meaning some source code is public, not the data. Of course, using synchronizing between these two repositories, and of course locally storing it. You can use GitLab issues for tracking issues. Also, well, we have our own library cloud storage. If that's another option, of course, might be simpler to start if those who are not used to Git. But I believe everybody should know a little bit of Git, just the tiny basics, because that's the standard now where we're moving for code repositories. Not only code repositories, we're moving also for sharing just notebooks, meaning when I say just not the computer code, but mostly also research, mostly also. So GitHub, those who explore GitHub, there's a very, very wide ecosystem out there. Okay, so how do we do this actual? So once we have our text, we have done the cleanup, done all the work, 80% of the work is done. Well, now we are ready to feed our text, plain text for markup, meaning semantic markup. We want to get lemmas, we want to get tenses, genders, and so on. So Spacey, Sketch Engine, again, these other services. Well, Latvian language is not quite well there. English good, excellent, I'm sure, but Latvian is not there. So we use this research project at the University of Latvia, Computing Center, and well, it's basically a back engineered REST API. So we do, again, it had needed some work to work with it, and so we get back results as JSON. So, and we get, what do we get? We get named entity recognition, we get syntactic structure, word dependencies, we get lemmas, we get tenses, we get genders, and then we can start making sense of this JSON format. Again, JSON is very, doesn't have strict schema. It doesn't have strict setting like maybe XML does, or so it could be quite flexible, but this flexibility comes at the cost that you need to interpret it, quite more open to interpretation. So storage. Once we have in JSON, we use pandas again for transferring, transfer to CSV, which everybody can use. The cost, the drawback with CSV is, of course, they are huge. Then you, of course, you have to zip them, compress, and that's again not good. So rather, that's another issue. So I have slowly migrating to storing also not only CSV but Parquet. This is an Apache project for handling big columnar data. It's about 6-7 times more compact than CSV. So the only issue is, well, it is open source project. It's Apache is a big organization which supports various projects, but it's not. You need some drivers to read them on Windows, for example. That you can't just open like CSV. The end result, you can think of it as a zip CSV, but well, with some extras, right? So you need some drivers if you need to work with it. So of course, so we keep both CSV and Parquet format. Okay, so analysis. Well, there's lots of venues for exploration, but we usually start with, so you can see here an example. This is after I have worked with JSON and converted to some table format. You can see what we are getting back from our A-lab. So we get our lemmas, we get our word form. This is in Latvian, right? We get our parents and sentence structure. We get lots of features here, which you can need to split them separately more if you want to explore them more. You have always split the word types, right? And this is sentence index, which this is a long sentence. So something like, so this you can start working with this immediately, even if you're not familiar with previous tools. You can even open up in Excel if you want, but probably not. So yes, on deeper introspection, we can do some grouping by genders, by tenses, by lemmas. You can do some time series analysis when we have time. In this example, we see Latvian use in a poetry, how word cloud, how much Latvian poets like to use cloudy words, cloudy lemmas, you could say. So again, we're using Plotly here. This is a little bit stretch here in this example, and of course you can explore it here. It's in a real notebook. It will be interactive. So yes, another option is plotting results. I guess so. Using results for Plotly. This is again more frequency, but with some extra dimensions. and you can explore this. You can filter it. Again, in our experience, what is much better than Matplotlib. You can customize this. This is customized, of course, quite well. You can pretty much change anything. The look. If you have a work with designer, you can add some nice customizations and then implement them. So quite recommended. Quite recommended. So yeah. So what's further work? I just covered just the very like top like the just the very basics. The integration, we have right now multiple tools, notebooks, scripts, and they usually are good for each step of the pipeline. The tool, the goal would be, one of the goals would be to make it complete, meaning put them all, glue them together. I mean, it's already working in the prototype stage, but it needs more for work. And again, ease of use. Again, if you had more time, I could show you how could we make it more accessible to somebody who is not a programmer. Again, the idea is you could use something called IP widgets. You can use some buttons. You can use some controls. So somebody who is not a programmer could start using this just like any other web-based tool. So, and of course, the availability is right now it's accessible locally. The idea is maybe eventually some of these services which are developed in the sandbox, we could move them outside the sandbox into our general infrastructure where you could use them as an end user, just a regular person. So you could use them and hopefully gain you have some gain and it would help you. Okay, so that's very short. I'm looking at, I think I'm running a little bit over time. So that's just a short overview what we have been doing at the library as far as these notebooks, these sandbox based tools, on what kind of what are the tools we use. So let me go again. So thank you.